Well, hello! Dancing Fetus here, and we're picking up where we left off on the last episode. On the last episode, I created this sweet calc angle method in order to get the player sprite to kind of follow the slope of my platform sprites. Works both angles. It doesn't look as pretty as it should, but well, that's what we're going to be working to fix. So in this episode, what we're going to be doing is we're going to get our player here to rotate to the angle of the sprite so it actually looks like it's landing flush on it. We're also going to fix a problem where the sprite actually looks like it floats above the platform, and this exists because of the way I'm calculating the Y position I'm sending the player, because I'm still basing if the platform sends the player a Y position based on if the player sprite falls within the width of the platform sprite. And when you rotate the platform like this, the platform sprite's width still comes out to here. If you look at my player position, it's still going out to the width of the sprite, and so I have to calculate the actual how far on the x-axis the player can travel before it falls off the actual like top of the platform. And we'll be fixing those two things this episode using my genius programming, or hack programming, whichever you would prefer to use. Well, my friends, some work has been done, so much so that I thought it might be interesting to do a side-by-side comparison of scripts. Over here is what the scripts looked like when I started this video, and here's how they look now. This is my player script, and really this one hasn't changed that much. The biggest thing to note is the fact that I am no longer getting a list of floats. I'm now getting a list of platform settings, which platform settings is a data type that I defined as a struct, and it contains the platform Y position, which is originally the only thing my world Y positions was holding, because originally when my player was over a sprite, that sprite would then send it the Y position the player would have to land on. Well, now it's sending that as well as its quaternion. I don't know how to pronounce it. It's basically the rotation of the sprite. And we need this in order to rotate the player so it looks like it's landing on it flush. So basically the logic is identical. It's just that now, instead of just picking the highest Y position and telling the player that that's as low as it can go, it's now getting the highest Y position, telling the player that's as low as it can go, and then also the rotation of that platform. On the world script side, there's been a lot of housekeeping more than anything. I've defined some more variables, and I'll go into those. I've added a bunch of comments because I was defining so many variables and I was forgetting why I defined them, and I had a bunch of variables that kind of overlapped and were doing the same thing, and so I just pretty much made a whole bunch of comments in order for me to remember why the hell I defined them in the first place. And then also on my start method, I'm defining a whole lot more things here, and this is really just for readability for me. In my before script, in the update function, I'm doing a lot of get component thing that I'm wanting to get, and then the object in that thing I want to manipulate. I'm doing that a bunch in the update method, and so I saw that looked a little ugly and it was muddying up my code. So now all I'm doing is really defining those into variables up here, and just doing the get component thing once at the top, and then down in my update methods, I'm just calling those variables I defined. The big change is this set sides method that I wrote, and what this does is it sets the x-axis width that the player should fall between in order for my platform to send the player its Y position and rotation. Instead of using it based on the width of the sprite renderer, which was causing that weird thing where the player would actually go off the platform but still be in the width of the sprite, this is what this solves. And it uses a math concept called Pythagorean theorem. Pythagorean theorem is a way that you can solve the sides of your triangle. Classic triangle math is this is your A side, this is your B side, and this is your C side. And Pythagorean theorem is simply the formula a squared plus b squared equals c squared. And we already have two of the sides. The first side is literally the width of the sprite. So from here to here, that's one side of our triangle. It doesn't matter if we rotate it. The width that we care about is still going to be the same. And this is going to be our hypotenuse, so our C side. Our next side is literally just going to be the length of the sprite. So from top to bottom, whatever that distance is, that's going to be our other side. And so now that we have this side right here, which is the hypotenuse of the triangle, and then we have the A side of the triangle right through here, we can now use Pythagorean theorem to solve for this distance right here. And that's going to be our x-axis width. So we're going to say that if you fall between this distance here, stay on the platform, but then if you go over that, which would be in this area here, fall, because you're no longer on this part of the platform. All right, we have our A side and we have our C side. So using Pythagorean theorem, which is a squared plus b squared equals c squared, we can just use a simple algebraic equation, which is c squared minus a squared equals b squared, and then just give the square root of that, and I got my b side. And this is what my set sides method does. This is what that formula looks like in code. What I'm doing is I'm squaring my size x, which size x, if we look up at the top and read this wonderful comment, size x is the width of the sprite when the z is rotated to 0. This is my hypotenuse, so this is my c. So I'm doing my c squared, which is right here, and then I'm getting my a side by just saying this object extent y plus this object extent y. So that gives me the maximum length of my sprite renderer. And then I'm just squaring it and subtracting it from my squared hypotenuse and getting the square root. That gives me the B side of the triangle. Actually, on my triangle, it is the C side, and that's because I don't know how to letter triangles. So I'm using this value here to set my max left and max right, depending on how far, like what side of the triangle is lower. Either it's the left side or the right side. And now instead of basing my if statement on the sprite renderer width, I'm basing it on this max right and max left. So the effect of that is, yes, and I went a little batshit insane with the platforms, but the effect speaks for itself. Look at that. Did you see? Did it do that crazy garbage thing where it just keeps going for eternity? And oh yeah, you probably also noticed that my player is rotated, and that was due to the fact that I have that struct, which has both the Y position the player should be landing on, as well as the rotation the player should have based on the rotation of the platform, and I think that is pretty swell. Well, it's been another math-heavy episode of Worthless Coding Challenge. It's been fun. I'm personally learning a lot, and if you want to see exactly what I'm doing, definitely check out my GitHub and just download my whole repository. I have a couple projects on there, and feel free, for real programmers out there, to rip my code to shreds, because I really don't know what I'm doing. But as always, thanks for watching.